Hi and Assalamualaikum. My name is Nur Izzah binti Yasmin. My metric number is A2803986. Today I'm going to be presented about the variable that we use in our report assignment statistic. Data description is the process of describing and presenting data in a practical and comprehensible manner. For this project, a dataset of 400 observations show us a dataset of Chai car seat at 400 different stores. Based on the group member with the lowest metric number, we choose 150 randomly chosen case out of 400. This table numerical data and categories have been employed for categorizing these variables. Numerical data are quantitative, while categorical data are qualitative.
My name is Nur Laylatai binti Karizam and my metric number is A22A0889. Now I would like to present about number of classes and class weight. For the number of classes, the income, age and price is all the same, which is 10. Meanwhile, for the class weight, the formula is maximum data entry minus with minimum data entry divided by number of classes. So here the class weight for income is 10, class weight for price is 14, and the class weight for age is 6. Next is mean. The formula for mean is sum fx divided by n. So the answer for income is 71.99. The mean for price is 114.57 and the mean for age is 54.13. Meanwhile, the formula for median is LM plus N divided by 2, sum of FM minus 1 divided by FM times C. So the answer for income is 73. The median for price is 115.5 and the median for age is 54.67.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Faris bin on matrix number A22A0874. I will now continue our presentation with the calculation of mode and range. As for mode, the formula is mode equal to lower class boundary plus difference 1 over difference 1 plus difference 2 times C. The answer for this question is, as for the income, the answer is 74.05. As for the price, the answer is 117.1. As for the age, the answer is 58.5. As for the range, the formula is range equal to maximum data entry minus minimum data entry. The answer is income equal to 99. As for the price, the answer is 138. As for the age, the answer is 55.
Hi and Assalamualaikum. My name is Nur Aisha Natasha binti Muhammad Zulfikri. My metric number is A22A0844. And for this presentation, I'll be presenting about the variance and standard deviation. For variance, as you guys can see, the formula already been written there. So the variance for income is 715.40 and for price is 514.29 and for age is 231.76. Moving on to the standard deviation. So the income is 26.75 and for price is 22.68 and for age is 15.22.
Hi, my name is Nurlisa Nabiha binti Muhammad Ishaq with metric number A22A0217. Now, I will continue the calculation for first quartile and third quartile. To determine first quartile is equal to LBQ1 plus N divided by 4 minus with FQ1 minus 1 divided by FQ1 times with C. So the calculation for income is 50.75 while price is 98.95 and the age is 41.81. So to determine third quartile equals to LBQ3 plus 3N divided by 4 minus FQ3 minus 1 divided by FQ3 times with C. So the calculation for income, price, age is 93.91, 131.83 and the next is 66.21 respectively. Last but not least, to know the gaps between Q1 and Q3, this study will calculate the differences between quartile 1 and quartile 3. The calculation of income is 43.16, the price is 32.88 and the last one is 24.4.
Assalamualaikum everyone, my name is Nuri Afrina binti Norizal and my metric number is A22A0915. Today I'll be presenting a graphical representation using a histogram chart. For section 4.1, we opted for using a histogram chart to visually convey our interpretation of the data. Our histogram is based on 5 class interval 20 to 39, 40 to 59, 19 to 79, 18 to 99, and 100 to 120. The frequency and midpoint of each interval are crucial metric derived from our data, the midpoint representing the average of the lower and upper limits of each classes are positioned at 29.5, 49.5, 69.5, 89.5, and 110. Notably, the class interval 60 to 79 is the highest frequency, while the 100 to 120 interval highest midpoint. The graphic input of a scatter plot is a graph that shows how two numerical variables are related to each other. It uses dots on a graph to represent data points which are variable on the x-axis and y-axis. Next, for the section 4.2, the frequency and midpoint are shown for the histogram plot. In table 2 and graph 2 is about price. There are 7 class intervals which are 24 to 43, 44 to 63, 64 to 83, 84 to 103, 104 to 123, 124 to 143, and 144 to 163. Next, the midpoint has to be found. To construct the bar chart, midpoint show the sum of the lower and upper limits of the class and it is divided by 2. The midpoint are 33.5, 53.5, 73.5, 93.5, 113.5, 133.5, and 153.5. Last but not least, for the section 4.3, we use a bar chart. Bar charts is rectangular bars of various lengths are used in the bar chart to visually divide data by displaying the amount or value linked to various categories. The frequency and midpoint are shown from the histogram in table 3, graph 3. There are 6 class intervals which are 25 to 35, 36 to 46, 47 to 57, 58 to 68, 69 to 79, and 18 to 19. Next, the midpoint has to be founded to construct the histogram. Midpoint show the sum of the lower and upper limits of the class and it is divided by 2. The midpoints are 30, 41, 52, 63, 75, and 85 respectively. The class interval 56 to 68 is the highest frequency, while class interval 80 to 90 is the highest midpoint.
Hi, I will continue with SPSS. There is a difference in values between manual calculation and calculation using SPSS software. But in this part, I will present the interval 1, which is income. This is because all the item is same, which is we have to analyze the value of mean, median, mode, standard deviation, and variance. These are different in terms of two calculation. However, the value of range is the same. The mean total for income in the SPSS calculation is 71.88, while the mean total in the manual calculation is 71.99. The total difference between these two calculations is 0.11. The median total in the SPSS calculation is 72.50, while the median total in the manual calculation is 73. The total difference between these two calculations is 0.5. Next, the mode total in the SPSS calculation is 69A, while the mode total in manual calculation is 74.05. The total difference between these two calculations is 5.05. Furthermore, the standard deviation total in SPSS calculation is 26.98, while the standard deviation total in manual mode is 26.75. The difference between these two calculations is 0.23. And last, the variance total in SPSS calculation is 727.77, while the manual mode is 715.40. The difference between these two calculations is 12.37. Nevertheless, the range demonstrates the same amount in SPSS and manual calculation, which is 99.
The next one is hypothesis testing. There are 5 steps on how to reject or fail to reject the hypothesis in a one sample t-test. So the first step is to state the hypothesis. The second step is to set the significance level. The third one is to compute the test statistic. And the fourth one is to determine the critical value. And the last step is to compare the test statistic with the critical value. So for step 1 is to state the hypothesis. The population mean is equal to the test value. So in this case, it is 0. So the second step is to set the significance level. So for this, the significance level is 0.05. The third one is compute the test statistic. In this case, the t-value for income is 32.633, 61.797 for price, and 43.023 for age. The fourth one is to determine the critical value. So the first thing first is we need to find the critical values related to the chosen significance level and the degrees of freedom of the t-test. In this case, the degree of freedom is 149. So, using a t-table or statistical software, we can find the critical values for a two-tailed test with the significance level of 0.05 and degrees of freedom of 149. The last step is to compare the test statistic with the critical values. If the absolute value of the test statistic is greater than the critical values, then we have to reject the null hypothesis.
The between groups variation for income, age, and price has a sum of square of 131,489.688 and 96 degrees of freedom. The mean square for between groups for income, age, and price are 1369.684. The within groups variation for all of them has a sum of square of 31503.5 and 15 degrees of freedom. The mean square for within groups for income, age, and price are 2104.901. The total variation is the sum of between groups and within groups variation, resulting in a sum of square of 163,063.188 and a total decrease of freedom of 111. The F ratio is calculated as 2.639, indicating that there is a relatively large difference between the group means. Meanwhile, the associate p-value is 1.799.
Alright, I will now continue our presentation with correlation analysis. This correlation table presents the Pearson correlation coefficient between three variables, which is income, price, and age. The Pearson correlation coefficient measures the strength and direction of the linear relationship between two variables, ranging from -1 to 1. Here, the explanation of the correlation. Correlation between income and price. The correlation coefficient between income and price is negative 0.148. This indicates a negative linear relationship between price and length. In other words, as the income increases, the price decreases. Next, correlation between income and age. The correlation coefficient between income and age is negative 0.038. This suggests a negative linear relationship between income and age. It implies that as the income increases, the age decreases. Next is correlation between price and age. The correlation coefficient between price and age is negative 0.087. This indicates a negative linear relationship between price and age. It suggests that as the price increases, the age decreases. All of these correlations are highly significant, P less than 0.01, indicating that the observed relationships are unlikely to have occurred by any chance.
Models show a strong positive correlation between income and age, with a coefficient of determination of 0.010 indicating 1%. The independent variable variation can be explained by the predictors. The adjusted R-square is negative 0.003 indicating reliable performance. The standard error is 15.325. In my conclusion, the study used various independent and dependent variables to analyze data. Graphs were created manually using calculation data and compared with the software. The distribution was skewed to the right, with the mean is greater than median, median greater than mode. SPSS software was used for the confidence interval, correlation analysis, statistical discrete measure, and hypothesis testing using t-test and ANOVA.